Hey, welcome back to Math Quest, guys. Today I'm going to show you how to evaluate expressions involving exponents. Whether we're multiplying them or dividing them, all sorts of exponents. It doesn't matter what they are. I'm going to show you how to manipulate them, how to evaluate them, and how to always make sure you get the right answer. After watching this video, you'll be an expert, just like me. Let's get to it. Come on.
All right, so let's take a look at this first example here. Before I start getting into the meat of what it means to work and evaluate expressions involving exponents, first I want to show you a basic exponent expression so you can get an understanding for what they mean. So here we have x to the power of 3. What this really means is x is being multiplied times itself 3 times. So that x right there is what we call the base. That up there, the smaller number, is what we call the exponent. So here we have x times x times x, basically multiplying 3 x's. That's what it means to have an exponent, that the base is going to multiply times itself 3 times, or whatever that exponent may be. So I hope that makes sense. Now let's get into it. So now, let's take a look at this example here where we have x to the power of 4 and x to the power of 5. Both of those are being multiplied together. So what that really means is that I have 4 x's here. Oops. 1, 2, 3, 4, all being multiplied together times 1, 2, 3, 4, 5. 4x's times 5x's. In all, I really have the same value, whether that's a 2, a 3, a 100, whatever value it is the same value being multiplied times itself over and over and over. So what value is being multiplied times itself? In this case, is the value of x. And the value of x is being multiplied times itself 4 times here and 5 times there for a total amount of 9 times. So this expression of x to the power of 4 times x to the power of 5 would be multiplied by, or would be simplified, by x to the power of 9. That would be my final answer in this expression, since I don't have a value for x. So really, if you think about it, all that I've done is, in short, because obviously I don't want you to be writing all these x's all the time, what I've really done here is taking the x to the power of 4 that was being multiplied times x to the power of 5 and simply added the exponents. So 4 plus 5, which gave me x to the power of 9. That's really all you're doing, and you can see you get the same answer. All right, let's take a look at another one here. Okay, so what about when we have something like this? We have x to the power of 3 to the power of 3. Okay, once again, what does that really mean? It means that I have x to the power of 3 being multiplied times x to the power of 3 times x to the power of 3. It means I have 3 x to the power of 3's. Does that make sense, hopefully? And if that's true, and if we follow the rule from last time, simply I can say that x to the power of 3 plus the other power from the other x plus the other power from the other x, and I would end up with x to the power of 9, right? That would be my final answer there if I was simplifying this expression. But once again, I don't have to show all this work. Really, when I have x to the power of 3 inside parentheses and an exponent outside of the parentheses, I can simply just take x here to the power of 3 inside the parentheses and that one outside. And what I'm really doing is x to the power of 3 times the power of 3. Whatever exponents outside, those two exponents are going to be multiplied times each other, getting me x to the power of 9. Hopefully that makes sense to you and simplifies things a bit better. So, a bit better. Okay. Here we go. Okay, I almost forgot. Let's take a look at this one right here. So if you notice, I have x to the power of 3 times y to the power of 2 inside parentheses, and I have a 4, an exponent of 4 outside. So simply that just means that everybody inside gets a 4, right? It's just like Oprah Winfrey, everybody gets a car. Well, guess what? Everybody gets a 4. So what that looks like, if you remember, we're going to multiply the exponent inside times the exponent outside. Because this right here, x to the power of 3, just means I have 3 x's multiplying each other. And y, I have 2 of them multiplying each other. So basically, 3 times 4 is going to be 12. So I have x to the power of 12. And then y to the power of 2 times 4, which is 8, right? And that right there would be my final answer. That's as far as I can simplify because I don't have a value of x and y. I cannot combine the x and y because they have 2 different bases, right? This could be a 3, this could be a 4. I can't combine them. Only when they have the same base can I combine it all together. All right? All right, hopefully that helps you. Let's take a look at some division now. All right, let's take a look at some division. Let's start out with the simple one, right? We have x to the power of 3 being divided by x to the power of 2. Okay, so what does this really mean? Once again, what this means is that I have 3 x's that are being multiplied times each other, right? Remember that. And all those are being divided by 2 other x's that are being multiplied times each other. Well, simply, you can see that those simplify. X divided by x equals 1. X divided by x equals 1. And I'm left with an x. So the answer to this problem is simply x to the power of 1. But we don't write that 1 there, right? So once again, how do we really solve these? Well, we have, let's see here. Let me scroll up. We have x to the power of 3 being divided by x to the power of 2. So what I'm simply doing here is x to the power of 3 minus the power of 2, which is the exponent from the bottom, which gets me x to the power of 1, or simply just x. That's all it means, and that's how you solve them. All right, let's take a look at one that's a bit more complicated, but they don't really get that much more complicated. Let's look at this one. Okay, so I really wanted to show you this one because this one's a little bit different. Now, some teachers may require that you keep all exponents positive. Some teachers don't matter and want you to write them both ways, positive and negatives. So really, the answer is still equivalent, whether it's negative or positive. But let me show you what I'm talking about, because you're probably like, what? He's going to throw in negatives? No, relax. Here we go. Let's take a look. So we got x to the power of 3 and x to the power of 5, right? So if I continue with the same process that I've been using, this is basically going to be x to the power of 3 minus 5 and y to the power of 7 minus 4. As you know, that is going to give me x to the power of negative 2 times y to the power of 3. And that would be my final answer. There's nothing wrong with that answer. But by now, you should understand that any base with a power that it happens to be negative is equivalent to a decimal. So the same as a fraction. So this is how we would write it as a fraction. So let's take it from here. So I'm going to bring this one down, the x to the power of 3, and subtract it from 5. So it's going to look like this. On top will be y to the power of 7 minus 4 divided over x to the power of 5, which is what I have down here. And I'll bring this 3 down here and subtract it here. So that's going to give me a positive exponent. As you can see, it gives me y to the power of 3 and x to the power of 2. This answer right here is equivalent to this answer. They're both equal. This one is just keeping the exponents positive, and this one It doesn't matter whether they're positive or negative, as long as you have an understanding that negative exponents are decimals. That's why it creates a fraction when they're all positive, because fractions are just done in the format of decimals. Here is really the last one I want to show you. You definitely have to understand this one. If we continue with the same pattern here of the meaning of our exponents and how to simplify them, this basically means that x to the power of a minus a, right? Well, a minus a gives me 0. So this actually equals x to the power of 0, right? Well, what is that value? Well, that value just has a value of 1. That equals 1. What? It equals 1? How does it equal 1? Well, remember, let's go back to our basic principles. Let's take, for example, let me create a little division here. Let's take, for example, x divided by x. You should know that anything divided by itself will always equal 1, such as 2 divided by 2, that equals 1. So if I had 3 to the power of 2 over 3 to the power of 2, or aren't those equal? You can tell right away that that equals 1. Well, if we take the same principle of solving these exponents, it would be 3 to the power of 2 minus 2, which would give me 3 to the power of 0, and that, of course, would equal 1. Does that make sense? I hope it really does. So what this really means, what I'm trying to tell you, is that anything to the power of 0 will always equal 1. All of these will equal 1. No matter what number, what variable it is, it will always equal 1. Positive or negative, they will always have a value of 1. Okay? Because a value, a base divided by itself, will always equal 1. All right. That's the last one, I promise. All right. You guys have a great one, and I'll see you back here next time on Math Quest. Goodbye.